Hi, everybody. Adam Savage in my cave, and I'm talking to you from among my Pantograph mill. This is one of my new favorite tools in the cave, and I was recently using some 3D printed patterns to cut a fake jade sword guard out of some G10 fiberglass sheet, which came out so spectacularly. I'm newly in love with this machine. But one of the things that happens when you're using this machine is there's two parts to it. There's a stylus, which goes in here, and there's a cutter, which is there. And when you are changing your cut, you're often changing the stylus and its relationship, depending upon the reduction you're doing. So if you're reducing something by 3 to 1, then my stylus has to be 3 times the dimension of this thing, et cetera, et cetera, et cetera. So this is the longest way of saying that doing this project necessitated undoing this little collet and pulling this thing out, pulling the whatever bit was in there out and replacing it. And I was confronted with the fact that, well, you can see here better than I can how this collet replacement system works. There's this pulley ring has a couple of, wait, where are they? Ah, there they are. This pulley ring has these these holes in it right there. You can see that hole? There we go. There's one on the opposite side. And when this tool was sold, it was sold with a tool that comes in and goes doink like this. We've all used them for angle grinders and other stuff. Special tool, a little half moon and 2 little posts. And it's lost. Super secret. You only ever need 1 post to change a collet system like that. So I stuck a 0.1875, I believe, a drill bit in here that fits this hole. And I did all my changing using this guy. But it's boring. It's hard to do. It's not really intuitive, and it's not the permanent solution to the use of this machine. And I will say that, you have to be careful with tools when there's a little friction to using them, because it's easy to be like, I don't need to solve that problem right now. I'll solve it later. And then in like a week and a half, you're thinking, maybe I'll use the Pantograph mill to solve this problem. You're like, oh, I'm going to have to change that bit like 20 times. I don't want to do it. And you come up with another solution. My brain does that kind of prioritizing all the time. And a lot of it is invisible or autonomic. But you don't want the friction of using a machine to stop that machine from being useful to you. That is my ultimate goal. Not you. I don't have to make a royal us. I don't ever want the friction in operating a machine to work against my use of it. And so that's why I set my tools up so in just the way that I set them up. I put everything that I need at that tool. I make the use of that tool as intuitive as possible to my process. And I change that all the time, depending on how I want to do that process. Okay, so what happens today is I am going to make a little change tool, and I might even make the little hex wrench, the 2 sides of the hex wrench that grab this thing. I think we're going to make a pair of tools today for the Pantograph mill. By the way, in order to figure out the dimensions of those holes, I used one of my favorite tools in the shop, my pin gauges. If you don't know about pin gauges look like this. They're precisely made pins. Yeah. I know this doesn't seem that glamorous. I can't tell you how much having this, and I've got them all the way down. This one starts at 61 thousandths and goes to 250 thousandths. 61 all the way to 250. Yeah. Yeah. And I've got them that go down to 11 thousandths and all the way up to 750 thousandths. And these are all in increments of 1/1000th of an inch. When you want to figure out what size hole you're dealing with in something like this, you can really, the fastest way is to pull out a drill index, because it's very likely that the holes in an industrial piece of equipment are in some fraction that is one we've all agreed upon, like the drill index fractions, 16ths, 32nds, etc. But the more accurate way, if you're wondering, is to grab one of these guys and then just keep on putting in successively bigger pins until you have gotten exactly where you want. And I believe I got the 1/8/7 to land in there. And I'm just going to have to look this up because my brain is old. Yeah, that's 3/16, 0.1875, although no one ever really needs that fourth decimal place. So what I did was I figured out that it was a 5/16 hole, and I took 1/8/7 and 1/8/6 and I put them in there. And then I measured, and they're both like stuck in really nice and straight, and they were parallel, and I measured their outer dimension, which is 2 inches. So this is my, this is it. That's my engineering drawing for this tool. Here we go. Okay, so the first thing I'm going to do to make this tool is I'm going to make the center hole, which it turns out I've got a annular cutter that will cut that beautifully. I'm going to cut it out of this piece of flat 1/8" cold roll steel. We're doing all 3 of these holes in one single operation. Stable. Go. Excellent. Okay, so let's get this out. Really hope this works. Let's see. Oh, right. I'm coming in. 0.1935. 0.1935. There we go. The number's sticking there. Yeah, let's do it. God, I love annular cutters. Look at that. Just dropped the little coin right out of there. Okay, now we're going to come back to 0, and we're going to go down again because we want flat sides. I'm going to go just as gentle. Awesome. Great. Now, move that out. Then we come in with our 3/16 bits. That gets centered, and then I go 0.907 in each direction. So that feels like that's too close. Okay, I'm just going to go with my measurements here, but I may have to recut this hole. Okay, and then 907 in the other direction. Out. All right. Well, that might actually work. Okay. Oh, you know what? I can test this right now. Let's take this over to the machine and see if it works. This is just going to nestle really nicely into. Oh, got it in one. And in, oh. Wait a second. Are they not? Oh, I'm not far apart enough. Wow, I've got to. Okay, so I got this the measurements are slightly wrong. Oh, actually, give me just a sec. Yes, it would appear that I'm about 20 thou off in this dimension. So I'm going to add 10 thou, 0.917, and I'm going to make these cuts again. So let's. This is such a beautiful shot. Let's get it again. There we go. Clearance. Okay, here we yeah, we're going to try this again. Let us test this new one out. Now these two are 20 thousandths farther apart than these two. Okay. Is it? It's, oh my God, I think I'm still. All right, I'm checking the first one again just to double compare because I'm in the middle. These are too close. These are too far. All right, time for Goldilocks. That's it. That was it. Amazing. Okay. So I went with a drill bit that was about 3 thou, 4 thou less. And then I also reduced the hole width, and that got my tolerances exactly where they needed to be. Okay. nice. I like it. It's all pretty rigid. It's all pretty parallel. Let's double check that action. Great, that's reasonably parallel. Parallel. All right, here we go. All right, not much to do but try it. Here we go. There you go. Come on, wet it out. Ooh. That's it. Okay, good. Now you're wet out. Okay. It's a little hot. Okay. Moment of truth. There he is. That was it. It slid right in. Oh, dudes. I'm so happy about that. Okay, so it's a little bit of a, I gotta make a mark there. Great. We can now cut this out, add a handle, and I've got a tool. That's great. Great. Okay, now we're going to peen that in. There it is. That's the one. And so then that can go there. And yep, okay, right. That's how that's going to work. Oh, let me. I can actually cut this down just a tad before I get started. be happy. $39.34. Okay, only a quarter of a degree off, so that should give me exactly what I was hoping for. Let's zero that out so I don't lose track of it. Should be at the same height, right? Yep. Oh! I was afraid of that. All right, I believe she is fixed. We're gonna let that cool. We're not gonna quench it. I gotta do this again. It's not working. I haven't included enough strength, and yeah, I think I've discovered that drill bits don't braze well to mild steel. So I'm going to remake this part, and I'm going to use another pin material than the back of a drill bit because I just had it completely fail on me. And we're going to start making this again. So third, fourth time, what is it? This is the charm. Well, you know what they say, 6 times the charm. Now I've got it. This is working. I had these lovely, wait a minute. Nope, they're steel. Woohoo! Thank goodness. Okay. So now I've got these steel rivets that sit in there. This is the right size hole. Everything is working out. I'm going to deburr stuff, and then I'm going to do some cutouts and then some brazing. That's what's about to happen. I know what you're thinking. You're thinking I could get much farther if I did more planning in the beginning. I wish I could tell you what it's like inside my head. There it is, a nice another wetting out. I swear I'm going to learn brazing sooner or later. All right, the tool is cooling down from the brazing. And I think what I may end up doing is a little bit of sandblasting, but not much else on this, just to kind of make it, oh yeah, I'm gonna, it's still really hot. And by the way, I did drop it out of this hand and somehow catch it with these pliers. I don't know how that happened. I'm gonna drill a hole in here so I can hang it somewhere. This is the only tool I'm going to get to today. I thought I might build the wrench that goes with that thing, but I swear I think I could just measure it and buy it. A nice flat parts changing wrench, like, you know, table saw wrench kind of thing. But yeah, let me get the sandblaster over here and let's mess with this thing. Okay, sandblasting was so much more successful than I suspected it might be. It came out so nice. Oh my God, that even finish just hides so many crimes. It looks so much more like I knew what I was doing. I gotta drill a hole in this. I'm gonna soften these edges down here, but I am leaving that little bit of brazing, which is from the previous attempt at this, just because I like the little extra history there. But let's drill this hole. Here we go. This is the tool. Wait, that's it. With my signature on it, stamped in there. Very happy. Let's go just check. Let's go check. Oh, here we go. Ladies and germs, look at that. Slots right in. Don't let the friction of using your tools keep you from using them. Make them as easy to use as you possibly can. That's my advice to you. Thanks for joining me on this. 6 times. See you guys next time.
Thank you guys so much for watching. One of my favorite things we make in our tested store are demerit badges. These are like scout badges, but for screwing stuff up, because screwing up is not just a part of the making process, it is intrinsic to it, and we like to celebrate that. We've got 27 so far in the Supervisors bundle that you can go buy right now by clicking on the link in the description, but we also have a booster pack of some brand new patches. This is the demerit badge for burning off your eyebrow. I am proudly sewing that to all of my clothes. This is the demerit badge for having a messy workbench, which I do not get today. My workbench is super clean. And we have new octagonal patches that are, merit badges. This is the merit badge for sweeping up your shop. Congratulations, I'm so proud of you. And this, oh my God, this is great. This is the merit badge for creating a clean space on your bench. Hey, we got to take our successes where they come and meet them there. Go to the tested-store.com or adamsavage.com to buy any of these, or click on a link in the description.